In this integral, we have given the sine function sine of t multiplied by the square root of 1 plus cosine t on the integrand, right? So that means we need to find the general antiderivative of this function. So how do we work on this? So as over here it looks like we have sine t is given, and then under the radical sign we have 1 plus cosine t, right? So there is no basic formula that will immediately help us to find the antiderivative of that. I'm thinking maybe because there is a kind of composition of, let's say, square root of t with 1 plus cosine of t or something like that. So with that perspective, I just want to see if we can use this substitution rule. So if that is the case, I just want to suppose, and let's say 1 plus cosine t, that's under the radical sign that I have. I just want to suppose that is my actually u, a new variable. So if I suppose in that way, and with the help of that, I just want to change this integral everything in terms of function of u or something like that. Right now it's everything is function of t, right? And then differential dt. What I want to do is try to change now everything as a function of u and differential du, and then just want to see when I change into that if that turns into the basic integral. Okay, so let's see if I can do that. So I have, suppose u is 1 plus cosine t. Then let me try to figure out what is differential du. So how do I find that? Differential du is the derivative of 1 plus cosine t multiplied by differential dt. So what is the derivative of 1 plus cosine t? Derivative of 1 is 0. Derivative of cosine t is negative sine t, right? So derivative of cosine t is negative sine t, and then now we just need to multiply by differential dt. So when I do that, that's my differential du, right? So I have figured out these two, let's say I have suppose one of the relation like u is 1 plus cosine t, and with the help of that I figured out the another relations, differential du is equal to negative sine t multiplied by differential dt. Now with the help of these two relations that I have just obtained, the idea is just use these in such a way that we can actually transform this given integral over here into a much more simpler integral, and then let's see if we can do that. Okay, so let's keep the integral sign here as it is, and then let's look into the term over here first under the square root sign. Here we have 1 plus cosine t, and then we have, suppose 1 plus cosine t is u. So if that is the case, instead of this square root of 1 plus cosine t, we can actually write down square root of 1 plus cosine t is u. So we can just write down square root of u, right? Now when I do that, whatever is left over here, so which is actually sine t multiply with dt. So those are the two terms left over, right? So sine t dt. So how do I change that into the let's say function of u, differential du, or in terms of u? How can I change that? So if you look into here on this second relationship that we have obtained over here, here is actually sine t multiply with differential dt, right? We can actually just solve for that. So let's solve for sine t differential dt. So if we solve for sine t differential dt, it's actually just negative of du, right? So you can just multiply by -1 over here on this equation, and we exactly get over here. So if that is the case, then what we can do over here is this sine t multiplied by differential dt that is left over here. Instead of that, we can just write down negative of du, and then since negative is just the sign, we can just take that out from the integral sign, and what is left over is just square root of u, right? And then our goal is to just find the entire derivative of square root of u by comparing with the given integral over here. So what we have received over here is much more simpler integral, right? Now why is it much more simpler? Because it seems like for me we can immediately integrate, because square root of u means something like u to the power 1/2 if we change it into the exponent, right? So this can be written as u to the power 1/2, and then now if it is just u to the power 1/2, then we can just use the power rule of the entire derivative, so which is u to the power 1/2. So we have that. So if you use the power rule, u to the power 1/2, its entire derivative would be u to the power 1/2 plus 1, so which is 1/2 plus 1 means 3/2, right? So that's what we have in the power, and we just need to multiply by the reciprocal of that, which is 2/3. So that is the entire derivative of u to the power 1/2, and we just need to now carry on that negative sign over here plus c. So this is the integral, right? So we have evaluated, but it is in terms of u. So but the given function was function of t. Our answer right now is as a function of u. So we need to go back to the original variable, and that can be done over here from this relationship that we have supposed at the beginning. We just need to replace u by, let's say, 1 plus cosine t. So let's do that, and then I think we are almost done here. So this is equal to negative 2/3, and u is 1 plus cosine of t, and then to the power 3/2 plus c, and that should be it. So this should be our the evaluation of the given integral.